Okay, so hello and welcome back to another Unity tutorial. In this one we're going to be doing part 2 of the item system tutorial series that we started last video. A lot of you showed support for this mini-series that I just started. I'm quite surprised about how many views it got, and a lot of you obviously really wanted more, so here it is. And for the next few videos at least, I'll be doing only this, so the next videos will all be item system stuff. I might throw in some other videos in between, but I'm definitely going to keep going with this until it's ended. So this video we're going to focus on writing the logic for the functions we defined last video. So we're going to be able to add items, remove at a certain index. We're going to be able to swap two items around, check if we have an item, get the total quantity of an item throughout the inventory, and so on. Just useful functions that we're going to need to keep calling. So we're going to write out the logic for that this video, and we're going to focus more on UI in its own video, which will be next video, so we can actually see this all working. You really need the UI to see this working anyway, because we need to test dragging the slots around to see if we can, pick up an item, put it in a slot, and so on. So sadly, we'll have to wait till the next video to see any, visual response of this working. But obviously, I'm going off my own project where this already works. If you haven't seen what we're aiming to work towards, then just check the beginning of last video. I've put this series in a playlist, so go find that if you want. The link might be just in the description below. But I showed what I've made in my other game. I could actually show you it now really quickly. Yep, so here's what I've got in my other game, which is what we're going to try making. So I have some kind of item container I can loot. I see items and their quantities and descriptions of the items that when I mouse over them. Obviously, this arrow is ammunition. It displays different data to this health potion, which is a consumable. I can loot all of them. If I go to my inventory, here it all is. The potions stack up to a max of 3, so obviously, because I picked up 5, we now have a new stack of 2 next to it. I can drag items around, swap them. There's some functionality you guys asked for that I haven't got yet in my own game, so off camera obviously I'm going to make it in my own game before I do a video on it. I'll try stack splitting. So currently, even though you could have 2 stacks and then drag them together and they become more, some of you might want this 20 arrows maybe to right click on it and type in 10, press enter, and then it spits out 10 next to it or something like that. That's what some people like. So that's something I'll probably try and do, split stacking. It's useful if you're trying to sell but not sell all. Or even then when I make a vendor and you walk up to it and interact, I might make a quantity seller, so you can click the item you want to sell, and then there'll be a little slider maybe, or a plus or minus, or a bit to enter text, or whatever you want, right, to choose how many of the item to sell. But we'll get onto that. This video is just solely based on getting the logic behind moving items around and stacking them and all that lot. Because in the next video, we'll actually build this UI so that you can drag them around, stack them, and so on. But before we get into the coding, I'd like to thank my patrons, so a special thanks to Flow State Games, Average Morning, Thomas Huster, Remy Baldwin, and Phil Baum. If any of you would like to help support the channel and community, the link is in the description below. Check me out on Twitch as well, and the Discord server link will be in the description below. But apart from that, now we can start coding. Okay, so we're going to start off where we ended last time, where we just put in the interface to our inventory for an item container, which obviously allows you to make other kinds of item containers that have different logic. Though, if all your item containers are going to have the same logic for how you add, remove, and all that lot, you could actually just make a separate class that is an item container, and we'll get onto that in a later tutorial if it makes sense for us to do. For now, this is fine, and if we ever do need to change it, all we need to do is just copy and paste our code from one script to another, so it really isn't that big of a deal. Let's just get the logic down. So I would start off with add item, but it's probably the biggest function, so I say we start off with the easier ones first, just to build up to that. So the easiest one is definitely get total quantity. So all we want to do with this is we want to loop through all our items and add up how many we've got, which is quite simple. The only problem is we don't have any list of items yet, so inside here we should probably make an item array. So we can have a private item slot array. Item slot is a class we created last time, or the struct, called item slots. We'll set that equal to a new item slot array, and let's say the inventory is size 20. That's just me. If you don't want your you set this as your inventory size, or if you want, you can actually just make this expose the inspector and you can choose the size of it. But I'm keeping it private so that because it's on a scriptable object, every time I press play, I don't want this to, save the items in it. We want to build our own save system. So now we've got an array of item slots. We can now write the logic for getting the total quantity. So we want to start off saying int total count is equal to 0, because we haven't found any yet, so we're going to start off with 0. We're actually going to return total count, But obviously between like getting it and returning it, we need to actually add to it the amount of items we've got. So we're going to say for each item slot in the item slots. So we're going to go through all of the item slots, and we're going to say, well, first of all, the item slot could be empty. So if item slot dot item is null, then we're just going to continue. So continue just goes to the next iteration of the loop. We aren't going to add this one on. Then we also want to say if the item slots item is not the item we're actually getting the total quantity of, so it's not equal to item. We also want to continue. So we're saying don't add on if the slot is empty, and don't add on if the item in the slot is not the slot we want, or is not the item we want, sorry. But then if these two things are fine, then we just want to say total count plus equals item. Now, sorry, not item, item slot dot quantity. So this slot has the item we want, so we're going to add on that quantity, and we're going to go through and do that, and once we're done, we're going to return it. So this will get us the total amount of an item. Okay, so has item is probably the next easiest. If you're using a list, a generic list, then there is just a built-in function for this. But for what we need to do, arrays are probably better, because they're less, well, they're more memory efficient, sorry. You only need to really use lists if your list size is dynamic, sorry, if it's ever going to increase or decrease. But during runtime, our inventory is only going to have a maximum of 20 slots, and you can actually set the size of that, but to be honest, our inventory is always going to be 20 slots big, so I'm fine to leave it how it is. You might want like a bag system in your game where you can add more bags of different like varying sizes, but that would be its own system entirely. So for now, we're just happy saying we've got 20 slots. And due to that, what we need to do to check if we have an item is say go through each item slot. So each item slot in item slots. If the slot's item is null, then continue just like earlier, saying, well, clearly this one isn't our item because it doesn't have any item. Then we want to say if item slot dot item does not equal the item we're looking for, then just continue. But as soon as it does, so you notice this is very similar to this, but instead of adding on the quantity of the correct one and continuing, all we're going to do is just return true. Because this function's purpose is to check if we have the item. As soon as we find it, then obviously we have it, so return true. And then here, return false, because that would mean we've got to the end of all our items and we haven't found it. So that's good to go. Okay, so swapping is not that complicated, but it's definitely more complicated than the other two we just made. Because swapping isn't always just going to be set one to the other and set the other back to that one. Because what can happen is you might have 2 health potions and 1 health potion, and you try and swap them essentially by dragging them onto each other. But you find out because they're the same item, and when you add the quantities together, it doesn't go over the max. You actually just want to add those 2 stacks together, just combine them. So we need to take that into consideration, but it's not too bad. So we might say swap slot 0 with slot 17 maybe, or whatever. So let's just cache, first of all, which is just a term for storing. We're going to store the first slot equal to item slots index 1, and then item slot second slot, because swapping's only ever going to be between 2, so this is fine to do this. Item slots index 2. And then all we want to do is we want to say if the first slot is the same as the second slot, return. Now this is actually going to work right away, because you can't just compare 2 structs saying if they're the same. What this really is basically if you pick up an item and you drop it, release it back on the slot it's from, you want nothing to happen, right? Because you're just dropping it back on itself. So the thing about item slots is they're a struct. So what we can do is we can go to the item slot struct, and we can just quickly write down here public static bool operator. You might have never used this before, but it's a way of defining what happens if you use equals between 2 item slots. Because obviously the C# programming language knows how to compare 2 numbers and 2 strings, and sometimes strings and numbers, right? It knows how to compare those kind of things. But what if you actually want to compare 2 structs? Now, in reality, this is a lot easier than you might expect it to be. It's just going to say item slots A item slot B, and the function is just going to return if the a dot equals b. So we're actually kind of just using a built-in system for this, but it means that it's this is just allowing us. Now it's not going to say it's okay until we've used not equals as well. We have to be able to have both. So we're going to say public static bool operator not equals, and then I'm just going to copy this. To be honest, it's just faster if I just take that and put that there. But we're just going to say instead of a equals b, we're just going to do not a equals b. So this might seem a bit pointless, but now it allows us, let me just see what this is about. Okay, that's fine for now. It's just it's not an error, it's just a warning. I'll have a look at that later. I haven't noticed that before, but it's fine, it'll work. So now we can actually say equals between these two structs to see if they're equal. It's just a niceness feature. Now, what we want to do is we want to see, so item slot, first slot is what we're dragging, and second slot is what we're dragging onto, okay? So we're going to say, if the second slot item does not equal null. So if we're dropping it onto something that's already there, rather than an empty slot, then we want to say, well, let's check if the first slot's item is the same as the second slot's item. In that case, we know now we're dropping an item, a health potion, for example, onto another health potion. So what we want to do is we want to combine them as much as we can, really. So we're going to say int. Now, I didn't really have a better name for this. I'm just going to call it second slot remaining space. Sometimes it's okay to have a longer variable name if it's more descriptive. Like, that's pretty descriptive. So we're just going to say second slot dot item dot max stack. So the maximum for the item minus the second slot dot quantity. So that's just how much space is left in the slot. You might even want to just write a function inside an item thing, an item slot, to return how much space is left in it. That's actually probably a pretty useful thing. I'm not going to do it now, but that is a niceness thing. I might just do it off camera and you guys can see it on the GitHub, but it's just quite an easy thing to do. You could challenge yourself to do that. So now we know how much space is remaining in the second slot. So we can say, well, if the first slot's quantity is less than or equal to the remaining space, then that means we can just shove all the first slot into the second one. So we say item slots index 2 dot quantity plus first slot dot quantity. Actually, I don't need to do that, do I? Wait, what have I done? Plus equals. Item slots index 2. Item slots index 2. We can actually just say second slot for this. I didn't mean to do that. So we're going to add to the first slot, second slot's quantity, the first slot's quantity. And then we're going to say, because we've added all of the stuff onto it, we now want to just go and put in an empty struct to the first slot, just to essentially clear the slot now. So item slots index 1. Now we have to actually reference which index now, because we're not referring to this anymore. We're referring to just the thing in that position now. It's a bit weird to get your head around if you're not used to doing this, because this is a specific item slot, whereas this is a position in an array, and that value has changed now because we've tweaked it. So we're just now going to say that's equal to a new item slot, new blank empty slot, and then we're just going to return like so. That's good to go as far as I'm aware. Thing is, in my own code, I actually wrote here the item slots index 2, and I know it works, so I don't want to risk it not working for now. So off camera as well, I will test that again, but for now we'll just leave that as item slots dot index 2 plus equals the quantity. Okay, so that function's done now. Oh wait, no, sorry. So that's what happens when we're adding, or like trying to put together two of the same item. But what if we're not? Well, let's go to the end, and we're just going to say, well, item slots index 1 is going to be equal to the second slot value, and item slots index 2 is going to be equal to the first slot. Okay, and that works pretty well. Okay, so now we're moving on to the remove at function. This is probably the simplest one actually now that I think about it. All we're going to do is make sure the slot index is valid, so it's between 0 and the length of the list minus 1. And then we're just going to set that slot to be a new item slot, so just an empty slot. And then that's it, pretty much. So we're going to say if the slot index is less than 0, or the slot index is greater than item slots dot length minus 1, return. So if it's out of the range, minimum or maximum, then we're going to return. So it's just a safety check. And then we're going to say item slots index, or slot index, is equal to a new item slot. So we're going to clear it. Actually, just for now as well, I'm going to put a comment here. So I'm going to put like invoke. This is just a reminder for me, because what we actually want to do when we change anything in the inventory, whether it's quantity or moving stuff around, so if it's actually physically changing stuff rather than just getting stuff, we want to raise an event to update it. Now obviously the UI updating is going to be in the next video, but it's still probably a good idea right now to put in these comments so I remember. So we want to put one in here before we return, because at that point we've changed, and also here after we've swapped those we've changed. So this is just to let the UI know, hey, the items have changed. Okay, so now we're going to be removing an item, but that means an item and a quantity. Obviously that quantity could be 1, but it could also be 10. So what we need to do for removing an item is we're going to loop. So for I is less than item slots dot length, I++, so just a normal for I loop, looping through the slots. If item slots I dot item is not null, then we want to say, well, is that item the one we're trying to remove? So if item slots I dot item is the same as item slot that we've passed in dot item. So if that's the same item that we're trying to remove, then we want to say, well, what if the quantity of the slot we're currently checking, if that's less than the quantity we need to remove, which is item slot dot quantity, then in that case, we can just remove it and we're done, basically. So we can say quantity, one sec, sorry. We can say item slot dot quantity minus equals the first slots, item slots I dot quantity. And then we could say, well, item slots I is now, we've removed all of it, so it's just a new item slot. Okay, and then we want to say else. So what if it's the right item, but there's too much of it? Like we need to remove 10, and there's only 9. Oh wait, no, and there's only so if item slot quantity is less than that, yeah. Now we need to check if we've got too many. So let's say we're trying to remove 5, but we've got 10. We still want to remove 5 from that list of 10, and then we're done, basically. So we need to say item slots I dot quantity minus equals the quantity that we're trying to remove. Then if item slots I dot quantity is 0, so essentially if the slot's now empty, then we want to say item slots I is equal to a new item slot, because that's done. And then I want to say we need to invoke the event now. So I'll just say, what did I just put invoke? Yeah. And then we return, because we're done. So this is how we remove the item. And because it's inside a loop, that means that if we're trying to remove 10 and we've got 2 stacks of 5, once it's done the first stack of 5, it'll keep going. So this is only when we're done. We're checking if... Oh, wait, sorry. I think I did that loop wrong. No, that's fine. That's fine. And now finally onto the big function, the add item function. There's quite a lot to think about when you're adding an item, surprisingly. It's not just a case of chucking it in a list. So I'm going to obviously explain the different scenarios as we go through writing this. And this could probably be refactored, but it's the way I wrote it and it works just fine. Though if there is a simpler way, then feel free to let me know. But let's get into it quickly. This video is just focused on the logic in here. We won't be doing any UI, so this is probably going to be the last thing I do if the video, it depends how long it's been going on for. I'll check after I've written this. So we're going to loop for all the item slots again. Item slots dot length. We're going to say if the item in that position is not null, so if there's something there, then if item slots item is the same as the item we're trying to add, then we want to store an integer for the remaining space in that slot. So it's just like when we were swapping earlier. Slot remaining space is equal to the item's max stack, so .item.max stack, minus the thing we're trying to, oh no, minus the quantity, sorry, quantity. Then we say, well, if the item we're trying to add on's quantity, so if essentially if we're trying to add on 5, if 5 is less than or equal to the remaining space, then that means we can put it all in and we're done. So this is the easiest bit, is well, we can just say add the quantity on. So item slots i.quantity plus equals the item slot dot quantity. So add it all on, and then this is just, I mean, I don't know why I did this. This isn't necessary, but I'm going to set the quantity to 0 just to make sure. But it should all be added on anyway. And then we're just going to say invoke and return. We're returning an item slot, not a like boolean or void, and that's just because we can then tell the thing that called the add item what's left. So if we added it all on, then we're going to get back a quantity of 0. The thing knows all of it was added on. But let's say we try and add an item of stack 10, but only 5 can get added on. Well, we're going to add the 5 on and tell it back, hey, only 5 was added on. So return item slot. So we're actually returning, we're returning the thing that was passed in, but it's going to have different data. It's going to have different values. But then what if the quantity is not less than or equal to the slot remaining space? Well, in that case, we'd say, well, else if the slot remaining space is greater than 0, because it's in that scenario, we need to then say, well, item slots i.quantity, we can add on however much space is remaining, and then tell the item slot quantity to take, dot quantity to take off that slot remaining space. So we're going to add that difference into it and remove it from the amount to add. So that's when we can add some of it, but not all of it to this. But we're in a loop, so obviously we'd try and add it in the next available space and then keep going. And then we want to say, well, what if this is doing a check to see if the item's already in the list? Because ideally, if you're adding an item to an inventory, you want to put it into its already existing instances of the item, if there are any. But what if there aren't? Like, what if you've got an empty inventory or you have found a new item? Obviously, it needs a new slot to go in. So we need to loop through all the item slots again now. We need to say if the item in that particular slot is null. So we're trying to find an empty slot. That's the point. If we find an empty slot, then we're going to say if item slot that we're trying to add on quantity is less than or equal to the max stack of itself, so dot quantity, dot max stack, then we're going to set this empty slot we've just found to be equal to us. So we've now found an empty slot to go put ourselves in. So then we're going to say, well, the item slot dot quantity is 0 now. So the item we've tried to add on, we've done with it. The reason I actually set this to 0 is so that when we return it, the thing asking, as I said, it knows if the quantity is 0, then all of it was added on. We can do an invoke here to say, hey, we've changed the inventory, and then return item slot back, so the caller knows what's going on. But then also there is the scenario that doesn't happen, where you're trying to add on, let's say you're trying to add 15 of an item, but actually the max stack is 10. Well, that can happen. Like if you are adding all from a chest and you add like 20 potions, but the potions only stack in 5s, you actually need to make 4 stacks of the 5 potions, or like 4 stacks of 5 for each one. So item slots I will set it equal to a new item slot with the item that we're trying to add on, but the actual quantity, what's going on here? New item slot. The quantity is actually going to be the maximum quantity of that item, whatever that may be. And then we can remove from the quantity we're trying to add on that amount. So item slot dot item dot max stack. And then finally, if we get to this point and then we're done, so we're going to be done right over here, we're going to say like invoke, which we'll get to, and then return item slot. And we're done with the inventory now. Okay, really quickly to end this video off, just as something we can do now rather than later, is we can make that event that I was on about invoking, and then obviously when we get to doing UI in the next video, you can see all this at work. There'll be a little bit of coding next video, but it'll be pretty much just setting up the UI and like linking the code to it. All we need to do is say public action, which requires the import of system. Public action on items updated equals a new delegate. You don't have to set that, I don't think, but just might as well give it a default value. And then in all these places where we've said invoke, we'll just say dot invoke. I'm just going to copy and paste that. So yeah, we can raise this event, and then anyone that's listening into this event can be updated. For example, we can update UI or whatever we want. So I don't think I've got, oh wait, I've got that one there. So let's zoom out and just give a quick scroll through. I don't see any more of those comments. Obviously we'll know when we're testing whether I've put it all in the right places, but I think I have. So yeah, now we've got our inventory. It's got functions for adding items, removing at a specific index if we need to, swapping items, checking if we have an item, getting the total quantity of an item for our inventory. So yeah, that's all the logic written. Okay, we can get onto the fun stuff next time, unless you find the logic fun like I do. But yeah, we can set up the UI, make it so we can have our item slots, we can drag items around, pick items up, and so on. So yeah, I hope you stick through the series. Obviously leave a like if you like the video, subscribe to the channel if you haven't already, check out the Discord server. I also stream on Twitch every 2 days, Tuesday, Thursday, Saturday. So feel free to check those out. This Saturday I'm actually not going to be streaming, it'll be Sunday instead, but that's a one-off. It should be Tuesday, Thursday, Saturday, every other week. So yeah, I think that's it for this video. If you do feel like helping to support the channel, then do that any way you can, but there's also the Patreon link below if you are feeling that kind. But obviously I don't expect everyone to be able to do that, and yeah, I think I've covered everything that I need to sell out about. So thanks for watching, see you in part 3, and goodbye.